On 28th of May, I was supposed to give a seminar on how to memorize 3x3 algorithms. Unfortunately, I was not able to give it, so I'll just briefly walk through whatever I've prepared. There were like at least a few, 4 5 people interested, and I disappointed them by not telling what I wanted to tell. So there are many ways to memorize algorithms. So first of all, whenever people really go into the domain of algorithms, when they really think that they are hitting a very hard barrier, where even after getting a better cube, they aren't improving, or their technique is a little bit slower, like a teeny bit slower, and they can't improve. So then they turn to algorithm. They resort to algorithms. Uh, what it's really hard to yeah, go with algorithms. So like we have to generate algorithms, then we have to find a way to drill it. Drill means do it again and again, and then memorizing it happens automatically over the course of time, maybe via finger memory or some sort. But then I really wanted to segregate this process out so that people can do it separately. There will be some generated algorithms in some algorithm sheets, and we just have to memorize them, and for a very long time. So using wacky story making process, I will try to like help you guys memorize 3x3 algorithm. So I asked a few people there at the nationals, which was 1 month back, 1 month back, and they said that uh, there are always triggers inside an algorithm, but like if the algorithm doesn't have any triggers, you can't make any triggers out of it, then you really need to change the algorithm. But I'll be discussing various kinds of 3x3 algs that are there, and sometimes we really are at the boundary. First we have to generalize what kind of algorithms really are there, and like for many CFOB users, we already know what this RU, R dash, U dash is. So that's the four move thing that is there in most of the algorithms. So let's move ahead. Uh, First of all, let me discuss the vast amount of algorithms that exist. Like there are many blindfold people who really are alg addicts. Like they'll generate algorithms, they share it a lot, and then they learn how to finger trick it. And finger tricking is really new ways of finger tricking are being invented just because of 3 blind, and that's really good. So there is a lot of algorithms in 3 blind, and there are a lot of buffers that people are choosing, and for corners it has been always variable, but for edges it has been one or two that have been always there. So it's blindfold algorithms. There are a huge number of them, and I'll be discussing how to break it down maybe. Then there are GBLL algorithms, which everyone knows. Every sweep hopper faces this barrier of GBLL, and it's not that easy to learn GBLL. You can know a few, but you can never complete a set without being fully dedicated. So that's a big barrier to overcome. So there are many good software developers who do cubing, and that's the good part of cubing. So there are many Java script like programs being made, or normal Java based programs. So there's a GBLL trainer made by Tao Yu, who is a really algae guy, and he has made really good trainer. And trainers are really good, and they should be used. But then if you really completely want to decimate a complete set of algorithms with the trainer, and if you're not finding the time with the trainer, you really need to have some kind of a story making process so that the alg can be retrieved. So it's just like learning new words in a language. You can drill it out, you can just speak, but if you are alone, and if you don't have any like a person who speaks that language, then you really need to find a way to memorize it. So kind of an association kind of a way. So uh, what if the algorithm is cannot be classified into some kind of trigger? Then the approach is that to we kind of break it down into blocks. The sequence of moves, we can break it down into blocks. So I find the number 4 very fascinating whenever we try to memorize. So like 4 moves at once, you can break it down, and this can be broken down as some kind of a mini sequence, and this mini sequence can be stitched out. If you are confused, I'll just explain in a bit. So like there's one-to-one mapping between each of the possible moves that are there, including the middle slice moves. So these are all the phase turns that are there on 3 by 3. As you can see, I've used all the letters from A to X, and I use the three index script letters, which I don't think so you should use it, but these are B moves, and we always try to avoid B moves in alg memorization. So I've just taken some letters, uh, attached them to every face turn, and that's how I form this map. I kind of should know this map, otherwise I won't be able to translate. So let's take an example of the famous TPOM alg, which every cube reviewer or every noob cuber really likes to do a lot. So these are the two algorithms. The first one is the most famous one. So the algorithm is 14 moves long. Yeah, it's 14 moves long, and it can be broken in three groups of 4 moves and the final 2 moves. It starts with the easy trigger R dash U dash, and you can easily translate it using this map as R U R dash U dash J A K B. Some kind of a person called Jacob. Then R prime F R2U prime KBLB. So there's a Indian brand of schools, Kendriya Vidyalay and lab. So guy named Jacob enters Kendriya Vidyalay lab. Then R dash U dash RU is KBJA, is Kabja. So that is being captured in Hindi. And then R prime F prime is KW, which is a cow notices this. So cow. So this is a big event. You just drill it in your mind, and when you know this map, you can easily remember TPERM. So now, why the hassle? Why the big hassle when you can easily remember TPERM by just doing it a few times? The thing is, like suppose you quit cubing for 10 years and you're back and you can't even do the TPERM. Maybe some stories stick very strongly, and you might be able to form this map and translate and do all this. Maybe it's another way of putting things in your mind. Okay, so let's tackle BLD algs, which are in the form of A, B, commutator. So in BLD, there is a lot of memorization and like the tracing itself when you are tracing the pieces. But then there's also the drilling of the algorithms for each kind of so-called letter pair. There's an algorithm, and if you're not using old Porkman, if you're using that old Porkman, then for every letter there's some kind of setup and swap. That's very inefficient way of dealing with face turning cubic puzzles. But okay, you can always do commutators on like most of the twisty puzzles. Okay, so what you can do is I form some one kind of way is that the setup move, there's always a commutator, and then before that there's the setup move. So the setup move can be the person part of the memorization. The first part of the commutator can be the action. The second part of the commutator can be the object, and finally this all is clubbed so that we have the visual cue to know this algorithm. So here is an okay, BLD algorithm. R dash U is the setup, then S prime, R prime, F prime, R, then S, and then R, F, R prime. So this is the whole algorithm, and then undo the setup U prime R. So if you are forming this correspondent, R prime U is PF, that's been puffed, then S, oh sorry, yeah, sorry, this algorithm, if I do it in my buffer scheme, it means PF, so puff. Then the setup R prime U is KA kangaroo, S prime is Q, and then R prime FR is KWJ, which is the Kowloon slums in somewhere in Hong Kong. I know this, so like you can have something else. But so how can I remember this is puffed kangaroo takes Q's and avoid visiting Kowloon jail. So for the letter pair puff, I know this combinator is there, and if I just it slips out of my finger memory, then I can remember the kangaroo taking Q and not avoiding the Kowloon jail. So I'll just remember R prime U, S prime, R prime F R, S, R F R prime, U prime R, like that for puff, which is P F letter P. Okay, so final type of algorithms which do not have any kind of triggers. So this is an edge flipping algorithm, lot of S moves, M moves. People like this algorithm. So it's R prime F R U prime M prime U 2 M U prime S R prime F prime R S prime. So again divided in 4 KVJB, a coveted job, little bit of okay, not exactly KV, I've used CV kind of thing. So coveted job, M prime U to M U prime is NCMB, is a nice multilateral business. S prime, S R prime, F prime, R S prime, PK W J Q. So to pick Woj, a coveted job in multinational, and the coveted job is really trivial and it's simple, and you have to pick the word Woj somewhere. That's how you memorize this algorithm. So suppose you miss out one of this thing, you forget them, then you really have to try it on the cube and recall what's missing. Otherwise this alg won't work, right? If you just have one move incorrect or missing, it won't work. So it's more important that you completely get the picture and you completely revise all the 3 lines and make one picture out of it, not two. Okay, so now the usefulness. This method is useful if you want to remember some self-made algorithms. You know, like there are always a lot of speed solving wiki algorithms, which many people have like given it to us, and it's really good. But sometimes we make algs of our own. Mostly they are very simple algs, 3-4 movers or some kind of a trick that we know. But sometimes like you make a big thing, like big algorithm without triggers. I don't know if anyone makes it, but if someone makes it, self-made algorithms, you can just immediately form this map and memorize it. So you can go in this direction, or you can always stay in this trigger direction. You can just remember the trigger of the algorithm and memorize it, which won't work in some cases. Will work in most of the cases. If you are practicing less, maybe you can do this. Like if you are not going for the speed solving, like you can rely a bit on triggers, bit on this technique. If you are 100% a speed giver, go for only triggers. But if you are someone who wants to like get fast, but not by turning faster, but getting more efficient in solving and in thinking process, like less effort on the brain, then you can try for this way of dealing with it. So why I have done all this thing, and like why is this thing out is till now, uh, till 1900s and 1980s, lot of people developed really nice cube theory, and it was really fascinating to be following then. Like, I was not born at that time, but if I were and I knew the Rubik's Cube, and if I knew the Rubik's Cube, it would have been an amazing experience, like living out through the 90s, trying out the Rubik's Cube. But recently, speed cubing has changed a lot, and this refinement process is only governed by how the top solvers use finger tricks and triggers, and how they which algs they use. So like before in the 90s, it was always like any amateur had a very big say. It's not only the top cubers, it's any amateur, and that was a really fun time for cubing, because it's like code development. So when you're coding, you're not always following the top coder. You know what's the benchmark, but you're looking for new ideas, and new ideas you can get from even an amateur. So that's why I really want cubing to have this kind of new way of dealing with new algorithms. Okay, so there are some limitations also. So many algorithms, they are finger trick using wide moves, RLF, and that I have not kept it in the map. Um, so like what I can do is I just introduce fatness. So these are fat turns or white turns. So whatever object is there, suppose that's kangaroo jumping or something, so fat kangaroo jumping, so that will take care of the wide move. And cube rotations, for cube rotations, uh, the only thing I've come up with is to break the image or shatter, break, something like that. And like for x direction, like chop off; for y direction, shatter; for z direction, twist and crumble, something like that. So this kind of actions that are destructive, that will describe this rotation moves, but I still don't think it's really efficient. It's really good to just play out the algorithms few times, drill it and know it. So that's, in that way, this is good. So so that okay, so I hope this thing is useful to you all guys, and like you can learn at least a few algorithms using this technique, if not for all. These are some of the references I've taken, so you should definitely check it out. So first one is from Tao Yu, and he has developed few applications. Then there is the Romans best site ever are you, which contains GVLL and BLDLs and everything. And there's the cubicle algdb.net, which has compiled, like nicely compiled algs and all that. So basically, I'll just tell why I was inspired to go for this story making thing for the algs. Like around 5 years back, when I was starting with queuing, there was a like very fast BLDR called Nikhil Monday, and he used to do a dance to remember alg. So he used to use hand movements for U moves, and feet movements for R moves, something like that, and clockwise, anti-clockwise, like that. He remembered the T perm using that, and even though it was not super useful, it was fun to remember an alg in that way. So, you can't really dance to every alg, so it's better to just form a visual imagery of the algorithm, and that can help a bit. I hope these examples are helpful, and you really improve. And all the best, happy cubing, bye.